The first step in our analysis is setting up the project environment. Open ANSYS Workbench and select Fluid Flow, Fluent. This will create a new analysis system. If necessary, you can rename your project for better organization. Next, right-click on Geometry and select Edit to open the Design Modeler. This is where we will define the computational domain for our propeller analysis. The computational domain is essential as it represents the volume where fluid flow calculations will take place. Properly setting up this domain ensures accurate and meaningful results. Once inside the Design Modeler, the first thing to do is set the appropriate measurement units. Navigate to the Units tab and select millimeters, as we will be working with metric units for consistency. Now, we need to create an enclosure around the propeller to define the fluid domain. Go to Tools and select Enclosure. This enclosure represents the space where the airflow around the propeller will be analyzed. The enclosure should be large enough to capture all relevant aerodynamic effects, but not so large that it increases computation time unnecessarily. The next important step is to align the propeller along a specific axis to ensure the simulation is set up correctly. In our case, we align the propeller along the x-axis because we want the airflow to enter from one end of the propeller and exit through the other. For the enclosure, define a cylindrical region that represents the primary study area. Provide appropriate dimensions based on the propeller size, ensuring that it is sufficiently large to capture airflow effects. A well-sized domain allows for better resolution of flow behavior around the propeller. After defining the cylindrical enclosure, create a second enclosure using a box shape and name it Surrounding. This surrounding enclosure acts as the outer boundary of our simulation. The dimensions should be sufficiently large to allow for an accurate simulation. Typically, the values are plus x-axis 800 millimeters minus x-axis 50 to 60 millimeters. Other axes adjust accordingly.